What if we look at the foundational infrastructure that is required to power the next generation of exascale AI? At this scale, resilience is also not just about recovery or even reliability. It's about foresight. One company is leading the AI infrastructure revolution, big time, and they do that with a digital twin. To show you what I mean by that, let's take a look at what happens when you combine the power of high-performance data centers for AI with physics-validated simulations. Tell us more about that, and that's pretty impressive. You're going to see more about that. I'd like to welcome to the stage Corine Winfield, VP of Data Operations and Business Analysis at Switch. Morning, Corine.
Hi, Dr. T. It's a pleasure to be here. Yeah.
Is that okay if I use my French to pronounce your first name?
Please do.
Okay. Corine is a French name. That's right. We have French people in the room. I meant awake, non-grumpy, and loud French people. So that video is spectacular. It's mind-blowing. The scale that Switch is building and operating things are insane and real. Can you tell us a bit more about what Switch is actually doing?
Yeah, so Switch is an AI infrastructure company. We're based out of Las Vegas, and we have campuses across the US. For over 20 years, we've been designing, building, and operating data centers around resilience and efficiency, and we continue to apply that same rigor today as we develop campuses of AI factories. And AI factories really are a new class of data centers. They produce intelligence in the form of tokens, and with that, they also require a lot of density of compute and power. And so it really brings forth a new class of problems that we must solve. Air is no longer an effective medium for heat reduction. We have to bring in liquid. Then you have to think about how to make that redundant and reliable. And you're looking at power and thermodynamics and harmonizing a multi-physics system. And so it really is a new class of problems to solve and engineering challenges. And that's something that Switch has been really good at solving. So our newest Evo designs, we're able to, one thing we do is apply model-based systems engineering and treat it as a system of systems. So that's borrowing from industries like aerospace, for example. And that enables us to semantically describe how deeply integrated systems relate to one another. So power, cooling, networking, and compute. We're not just constructing capacity. We are developing the operating model to deploy and operate AI factories with speed and efficiency. So just like a computer or server requires an operating system, AI factories require advanced hardware to be able to bring all those systems into harmony and generate intelligence. And that's why we simplified our hardware platform, developed a Trino-based data platform with all of our OT and IT data included, and we rebuilt our flagship software, which is our living data center. And that would not be complete, certainly not in 2026, without a very coherent visual representation of all the physical domains, and that's where our digital twin comes into play.
The famous digital twin. And before we go into that, I'm not sure if people realize that you're actually powering AI in the world. So there are like many companies using you. I know you don't name them, but like CoreWeave is based on like there's a lot of things that are running on Switch, and you can see that by the scale and the sophistication of what you're building in terms of AI factories. For that, you're using that digital twin. How does it help you achieve all of that?
Yeah, so it really, it is that coherent model that we can all systematically reason around. We initialize it during the design phase, so before anything gets built, we are able to validate key decisions before we go into construction. Then during construction, it really helps us to preserve design intent across all trades and crews and activities. And then once a facility comes online, the twin becomes a living model, self-aware with telemetry and relationships. And that really enables us to reduce risk, accelerate deployment, and keep mission-critical AI workloads running at the scale and density that our customers need.
That's really cool.
Yeah.
And you can use GPU to create visual simulation and not only AI, apparently. So that level of precision is actually also very exceptional. I was wondering how technically is the digital twin built? What are the components that you're using? You might be using some SUSE and maybe some NVIDIA. So if you can share a bit more with the people, what are the keys?
Yeah, so, well, we couldn't do any of this without partners like you. So our Living Data Center is that real-time software control system for Evo AI factories. It's the operating layer that connects the physical environment to the software so that we can design, build, and evolve our campuses for decades. NVIDIA enables a physics-validated simulation and 3D rendering experience with their Omniverse DSX blueprint. And then SUSE provides that trusted software supply chain and for our critical infrastructure with SUSE AI, providing the platform governance and shared infrastructure so that our software stack is repeatable and reliable as we scale. We need to work very closely with partners that share our vision and values. And we really are entering uncharted territories, taking technical leaps together, right? And so that's why we've been very intentional in partnering with you and the team and NVIDIA, because we strategically envision the same future, one where AI infrastructure scales fast for sure, but it's with the governance, security controls, and compliance guardrails in place, built in from day one. So appreciate being on this journey together.
Yeah, thank you. Thank you for our partnership. And we share this vision and value as well. We share that with a third partner who is going to join us. I'd like to welcome John Fanelli, VP of Enterprise Software at NVIDIA, to the stage. Good morning, John. Good morning. John, it's great to have you here.
It's great to be back again. Hello, everyone.
You were on stage
Long
yesterday
time no
with
see.
GP as well.
Yes.
So, you've seen the digital twin. I think
did.
actually you did contribute in terms of technology to that.
Well, I just have to say, you guys nailed it. You created an AI factory that creates AI factories.
Yeah.
Like that is like amazing, right? And so at NVIDIA, we think of AI as like a 5-layer cake, right? So you have power, you have GPUs, you have infrastructure, you have models, and then applications. And it's actually the combination of Switch and SUSE, along with NVIDIA, that brings all that together for you to create your AI factory. So it starts with the Blackwell system level or rack level systems at the beginning, and then layer on the SUSE infrastructure, SLES 16, designed for AI from the ground up, using Rancher Prime to manage everything. And then we pulled together the NVIDIA technology to help with the models, in particular the DSX blueprint that you're using, using the models to do the simulation. And then, like all AI factories, it does not only simulation, but also does AI. So the fact that you're using a single AI factory for multiple use cases is fantastic.